Welcome, everyone. Thank you so much for joining us today. I'm here to kick off the next session for the IIoT World ICS Cybersecurity Day. My name is Ellen Boehm, and I'm an SVP of IoT Strategy and Operations at Keyfactor. And I'll be going through a brief kickoff, introducing our panel, and then we'll jump right into questions. So just as a reminder, for your Q&A throughout the session today, please just look at the bottom of your Zoom panel and type your questions in Q&A. The chat is separate if there's sort of any sort of housekeeping or general comments you'd like to make, but Q&A is where we'd like to have your questions come in. So please use that. Additionally, there are other future events that IIoT World will be hosting. You can check them out on their website, but just know that October 26th, there is an IIoT World Industrial Metaverse Day, talking about AR, AI, VR, and so on. And then December 7th, there is an IIoT World Manufacturing and Supply Chain Day. So be sure to check those out as well. So we're going to be going right until the top of the hour. We've got 4 amazing experts to talk to us today. And before we jump into that, just want to say thank you again to our sponsors, Building Cybersecurity Organization, Fortinet, Eurotech, Keyfactor, Verve, and Zona. And lastly, just a reminder about this organization that is putting this on today, IIoT World. They're the leading authority on industrial IoT. IoT World is a digital media outlet that brings the latest industrial Internet of Things and ICS cybersecurity virtual conferences to a global community of over 284,000 people. IoT World focuses on delivering daily insights on the industrial Internet of Things across multiple verticals. And online, they're curating a series of virtual events which are drawing thousands of delegates and people into this conversation. So with that housekeeping out of the way, for today, I'd like to introduce our topic and then our speakers. So during this session, we'll be focusing on how product engineers can design cybersecurity into product components from the beginning and maintain that cybersecurity and strong root of trust throughout product lifecycle. We're going to talk about differences in implementing different pieces of infrastructure, including PKI, within IoT devices, within applications, and other elements that these devices need to connect to within the network. And with that, I'll introduce our first panelist, Andreas Phillip. He is a Senior Business Development Manager for Keyfactor. He has a degree in communications engineering and started his career more than 30 years ago as a developer in the field of card-based payment and hardware security modules. As a Senior Business Development Manager, Andreas focuses on integration and adaptation of cybersecurity solutions into the industrial IoT sector. And welcome, Andreas. Next, we have Morel Seik. He is the VP GM Head of Cybersecurity for Honeywell Building Technologies. He's spent over a decade embedded across various domains and has global experience leading from the front, doing engineering, operations, marketing, and sales. Most recently, he has dedicated himself to addressing challenges and driving new breakthrough growth opportunities, capabilities, and efficiencies, and promoting best practices around this ever-changing IT, OT, cybersecurity landscape. Glad to have you, Morel. Next is Guillaume Crignon. Guillaume has 27 years of experience in semiconductor and software, IoT security, radio frequency circuit design, project management, and business development. For 7 years, he's been really focusing deeply in IoT security technologies to bridge that gap between IT enterprise platforms and then low power connected devices. And Guillaume has recently joined Keyfactor as a Director of IoT Business Strategy within the global IoT team. Before transitioning to this role, he was an IoT Strategy Manager for security and connectivity with Avnet. And last, we have Maura Sagab. Maura is a cybersecurity leader with extensive experience in technology delivery and governance, risk and compliance in the energy and fintech industries. She's experienced at designing and implementing combined cybersecurity and physical security organizations to effectively manage risk and ensure compliance. She's led transformational programs to advance digital technologies, modernize the grid, and enable next-gen energy management in the grid of things. So very impressive background. I'm really thrilled to be able to have a conversation with all of you. So let's jump right into it. So I'm going to start off with this first general question. Morel, I'm going to pass it over to you to start, and then we'll see who wants to kind of continue on the conversation from there. But the first general question is, how do we define security by design?
Thanks for having me on, Ellen, and such a prestigious team to be on with. So really appreciate it. Great question. So let's dig a little bit deeper. Let's compare maybe two of the main areas of focus when we think about security in general from a design perspective and a development perspective. So we have secure by design. Now, that's the ability to apply cybersecurity functions, we'll call them, and designs to reduce any level of threat. So high, medium, low. So designing the system securely prior to any development taking place. So that includes things like designing countermeasures and mitigation strategies for potential exploitations, minimizing any service weaknesses for the applications that we're going to design. That includes systems, hardware, and any services as well. So remember, this is all at the design stage. So that's secure design. We then have the secure development side. So this includes anything developing, creating, maintaining, and actually coding any new or existing or modifying existing applications. So this could be your enterprise level applications. It could be bespoke programs. So this is doing the actual development work itself. So to summarize, we have two separate buckets, we'll call them. We have secure design, which is to ensure that the product is architected correctly. And then we have the secure development, which follows these architecture and design principles. And we can then add on the secure coding frameworks to actually build the product or service.
Thank you. That sounds like a really great framework to kick us off and define the conversation. So maybe if we could go a level deeper into that. Andreas, can you perhaps give us some perspective in how we go about this, maybe architecture side of security by design?
Yeah. I think one point is, and that is what we see over the last years, is also that the standards are now, or the standards and the regulations are now covering also this point. Yeah, 62443 has it exactly in their parts inside. That's a split between securing the device, implementing secure measurements, secure functionality, and also adapting this to the organization. Yeah, how to implement software, how to implement the production side. Yeah, as Alan mentioned, my background is financial industry. I developed stuff in the financial industry, and we were used to it. Yeah, and our development department, we were under the complete umbrella of auditing and being compliant. So, yeah. And that is exactly what we also see today in the IoT, IoT world, and that is also part of the production life cycle, of the production cycle itself. And that not only when a product is developed, also when it is born in your manufacturing site, and the security mechanism has to be built in also from the first step, before the initial software is loaded or something. And these are the requirements that we see today.
That makes a lot of sense.
Ellen,
Yeah, go ahead,
I would
Mark.
actually add as well, one of the things that kind of historically has been a problem is the secure operations. That when you're designing and developing, that you're keeping in mind that you're going to have to, you know, upgrade this device, and you need to make sure that that's something that's easy to do. I think I've come across situations in the field where, you know, there's an old OS running or something like that, and there's complications with respect to upgrading. So I think it's good to keep the operational kind of security challenges in mind as well when you're designing and developing.
Definitely.
That's a definitely great point. Yeah, oftentimes I like to think of it as a complete life cycle. And it feels like what you just added there is maybe one of the, at least the third step, and maybe even one of the longest steps when we're talking about ICS, you know, and or industrial products, because, you know, architecture, development, and design, that could be a few years even, right? If we think about normal product development, but then useful life of some sort of equipment, especially if it's a big asset, could be 15 or 20 years. And a lot of things are going to change throughout that lifetime, that useful lifetime, especially from a security landscape. So that kind of leads me into our next topic, which is around risks. So how do we quantify and think about risks that designers and architects need to be aware of when they're sort of embarking on this process for designing for cybersecurity? So maybe Maura, if I can stick with you to talk a little bit more about that. How do you kind of start with this whole risk assessment process, and what do people need to be aware of?
Okay, I think, you know, one of the kind of key drivers with this whole concept of security by design is a realization that the cost of retrofitting a device for security after the fact is considerably higher. And I kind of, I compare it to the old way of coding with the software development lifecycle, where you spend, you know, each, you know, considerable amount of time in each phase. And then by the time you get to the testing phase, which is right before you're going to deploy something, if you actually identify issues or bugs, at that point, you have to go back in the life cycle and retrofit. And I think it's always much easier to build something securely up front rather than try and bolt on security, as we say in the industry, after the fact. And like when you're thinking about the risk, I mean, you need to think about things that we all need to think about, even on the IT side of it, right? You need to consider like access. And, you know, I think we're going to talk about this later, the zero trust approach, right? You don't trust the people, the devices, the data, the applications, the services. You need to consider data minimization, and this is becoming even more important as we move forward with all the privacy regulation, right? You don't want to collect any data that you don't need. And then you need to consider the network, right? And this concept, I think, is true in IT and OT again. Most security professionals start with the assumption that the network has been breached. And then if you're going with that assumption, you know, how do you protect the particular devices from the network itself, right? And then lastly, like you need to understand the threats, right? Their tactics, their techniques, their procedures, depending on what industry or area you're in, right? It might be different. It might be nation states, it might be criminals, it might be hacktivists, but you really need to think like the adversary that's trying to compromise your device or your systems. So that's what I would consider with respect to this.
Great points.
To jump in
on
that, great points, Maura. We see this all the time, right? So we've got different levels of risk across different organizations. I think an important takeaway maybe is that some organizations perceive risk in different ways as well. some organizations may have a higher tolerance to accept risk, whereas other organizations may not. So depending on the tolerance of risk or the organization's risk appetite, shall we call it, we would look at applying different security measures or cybersecurity improvement measures. Now, of course, this goes without saying. We have to do secure by design. We should never make anything a bolt-on. We should always be practicing secure development lifecycle. But once it's in that operating framework, the things that we can add on top of that is dependent on the industry, to Maura's point earlier, and that level of risk appetite that an organization is willing to accept.
Great points. Thank you, Morel. Okay, great. So let's shift a little bit and think about some maybe practical basics that a person in the development side now, right? So think product engineer, cybersecurity, product engineer would need to consider when they're trying to design in cybersecurity into their product. So I'm going to start this one off with Guillaume. We'll pull you into the conversation. So can you talk to us about some of those basic components that a designer needs to think about when doing this? And mute. Thank you.
Classic. I do that all the time. Thank you, Ellen.
You're coming through loud and clear now. We got you.
Yes,
so what do you think?
Yes, I try to keep silent. So yes, when you're a product engineer and you need to design for cybersecurity, that supposes that somebody has done the job for you to identify the risks that your products will be subject to. So then I think that the first number one most important point is to follow standards. So cybersecurity is not something that anyone wants to brew in their own kitchen. That doesn't work. So you need to follow standards. Then as a product engineer, you need to make sure that the hardware you're building on allows to securely store sensitive materials. So like private keys that nobody should be able to read or write, certificates that may be read-only. And you also need to provide your devices with a unique identity, because that unique identity will be the foundation of everything else. With a unique identity, like we humans do have, you can build much more services, because it means that you can identify a device later, you can track that device, and you can uniquely recognize a device from a fleet of many others. So that unique identity is not anything easy to do or to provide. It usually happens at manufacturing. So you need, usually it's done with unique credentials, certificates, private keys issued by a PKI. Then you need to make sure that, because you're developing software, of course, software has a lot of flexibility, and nobody can develop the perfect software spot on. So you know that you will have to upgrade your software later during the life of the product, even when it's been deployed in the field. So you need to make sure that you have means to check your software firmware integrity. So it means that you have to have a flow where during your software or firmware production, you can securely sign what you do uniquely, so that no one can tamper with your software or firmware, and that when your firmware software is injected into your device in the field, you have mechanisms to measure the signature and to take action. So action can be either not boot, not start, or to start in fail-safe mode and to report that something's happening that needs a fix. You need to use specific keys and certs for that, because again, that's security we're dealing with. So you want to cluster and segment the usage of the keys, and you need to report constantly to the end user, to the admins. Fifth point, I think you need to implement secure communications. So from your device to whatever your application backend is. So usually it's a server. It can be device to device. So for that, you want to use, again, best-in-class cryptography. You want to use certs whenever that's available. You don't want to only rely on network security. That's important to mention. You want to assume, like we said, networks have to be assumed to be unsure and secure, and someone may breach into a network, and you don't want that to compromise your communication. So that means implementing the S in HTTPS or MQTTS, and that's very important. So there are standards to follow doing that. You need them to keep your software and firmware updated all the time. That's very important because again, you're not developing the perfect thing spot on, so you will provide upgrades. So have a flow for that. You need to have a secure bootloader to load that firmware and do the checks that we've discussed. The security itself needs to be upgradable. So we're not talking about USB or a video standard here. A USB, you can live on 2.0, that's fine. Security, you cannot do that. So whenever something breaks, you need to be able to upgrade your device. And sometimes it will be painful because you will have security crypto accelerators into your hardware, and the upgrade will not make it possible for you to use your accelerators anymore. So you need to provide secure software to do that, but you need to do it. So you need to minimize your attack surfaces into your devices. So make sure, again, to cluster your threads, your processors, your stacks, to make sure that you don't leave anything open. You need to understand how to make your system overall resilient to outages. So what if you lose the power? What if you lose connectivity? What if you need to go to a factory reset of your device? So what happens? Can the device re-enroll and onboard again onto everything? Can your system recognize that as a device and take the measures, appropriate measures for that? And then, of course, you need to monitor and examine all system telemetry data that you have available. So monitor the behavior of your device, detect any deviations from what's expected. So in terms of amounts of data exchanged, number of connections per day, for instance, usage of the device, and you need to respond timely to anything peculiar that may be happening.
Great. That was a lot of great tips in there, Guillaume. I'm not sure if anyone can add anything else to that answer, but I will just open it up. Is there anything else that, from your perspective, that you'd like to add, perhaps Morel or others?
Yeah, maybe I'll bring it up one level, because there was about 8 to 10 incredible things there, everything from PKI, Cybersecurity, making sure we've got the right encryption and all the rest. If I could point out 3 things that maybe set the baseline for all these things that Guillaume talked about. So first of all, creating a rigorous engineering spec. Sometimes we look at these docs and go, wow, this is a lot of data that's gone into this, but it really forms the basis of how we're about to approach developing a product. So having that engineering spec, and that will feed in the awesome things that were just discussed, right? Then when you think about just some high-level terms for the people listening here to Google, we need to have SDLC, Secure Development Lifecycle processes, and we also need to have a PSERT process. So it's a product security incident response team. So I think if something goes, all things going well, we've developed our product securely, followed the engineering spec, and if something were to happen, we can respond. We need to patch, we need to provide a hot fix, we have a playbook to go and do that. So there's some terms that we like to use in the industry, and they're the best practice principles. And then hopefully at the end of it, we'll have something that is providing good customer outcomes, is secure without bolt-on, and in case something happens, we've got a way to respond.
Awesome, great ads, thank you. So I do see, guys, in the chat, we do have a question that I'd like to ask now, because it kind of relates to a little bit of maybe the risks and the things we need to think about when designing. And so it's really about, how do you calculate the impact of designing cybersecurity when it could impact your schedule, it can impact the functionality of the device, or it can impact the cost of the device. And I know that that's always this this optimal triangle that we need to figure out, is how to make it secure and do what it's supposed to, but it's not that expensive. So does anyone have any thoughts on that, or maybe even a specific example of a project that you've worked on where, while again it seems costly, and I think there was a second comment around retrofitting, upgrading facilities, that does also take time too, but then what's the ROI? How do you make that worth it in the end? Does anyone have any specific thoughts on that?
Happy to kick us off here, right? So the way I'd look at it maybe in reverse. So what would happen if we didn't take secure design principles approach, and we were designing a new product today? Well, let's say that were to occur, and that product is released to the market, and then there is a cybersecurity challenge that presents itself with that product. Now, the impact to that is, well, you've just lost a revenue stream, because the likelihood that anyone's going to use your product now is very, very low. I think we can look at this maybe in reverse as well, to say, well, what is the impact if we don't follow secure design principles? And to be honest, these secure design principles now have become a lot more mature. There is still that challenge with retrofitting, absolutely. But if we were just building a product from scratch, I would say follow these best practice principles. To Guillaume's point, do not try to roll your own. They exist for a reason. That will reduce your cost to serve, and effectively bake in security, so that you don't get into those trappings of releasing a product, it's insecure, something happens, a very big breach, high level visibility, customer gets impacted, then you don't have a product, right? So that's just my high level opinion.
Makes sense. Yeah, Guillaume,
Maybe I could add. Yeah, maybe I could add something. I don't think you have to implement everything I talked about from scratch, but I think there are two things you need to consider. Start with the right hardware, because if you don't have the right hardware, it's impossible to retrofit. Okay, so you need to have that slightly secure processor, or that secure element, or that's something that will make sure that even later you can do things more secure than what you're doing today. And the second thing that you need to do is to make sure that you tag your devices with unique identities. If you don't do that, it will be very, very difficult to augment your security during the course of the life of your product. If you have those two things, it seems to me that they're not too expensive. So you can start rather cheap by having those two different things, the hardware and the identity, and then you can build on that depending on, well, what budget you need to allocate. But if you're not ready to have a full software development, secure software development procedure, you can implement that later, and maybe you can do things a little less secure to start with, but because you have that unique identity and you have that hardware, you have the capability to upgrade quick whenever you're ready. So it's maybe that's an answer.
Yeah, fair point. Great thoughts, guys. Thank you for this. So let's shift a little bit, because there's another topic I wanted to make sure to talk about, and I'm gonna start off with Maura, because I think you have some experience here, and then also Andreas, you mentioned it in your intro, but I'd like to talk about any regulatory and compliance drivers that we are seeing or you are seeing in this space. Now, that could be specific to an industry, specific to a region. There's a lot that we're seeing coming out. And so from your perspective, perhaps, what do we need to think about and be aware of and be tracking? So maybe, Maura, if you could give us your perspective, we can start there.
Yeah, sure. So actually, this kind of ties nicely into kind of making the case for security, right? And justifying the cost. This is always a challenge, like for cybersecurity, because it's about risk of avoidance, right? So often what I do is I will look at like what regulatory frameworks you're working within and what are the compliance obligations from a legal perspective in the area that you're working in, and use those to justify the investment in security as well, right? So you can't always talk about, like, you can't always put $1 or €1 to the actual risk number. It's very hard sometimes, but you can say, you know, we need to do X, Y, and Z because it's a requirement, right, for doing business in whatever area. So there's quite a few frameworks that you can leverage, thankfully, out there. And you know, one of the frameworks that I always work with when working with critical infrastructure on the IT side is the NIST, right, CSF framework, right? And then, of course, there's also, you know, NIST has some standards with respect to OT as well, right? So there's the NIST IOR standards. And then, of course, as Andreas mentioned earlier, the IEC 62443, right? So use those compliance frameworks to help you, right, build and operate, build, or design, build, and operate securely, right? So I often, sometimes it's hard to get money, or it's hard for people to kind of understand that you know, need to do X, Y, and Z. But when you tell them, look, it's the law, it's a regulation, you know, then it becomes easier to justify the investment from a leadership perspective. They don't always understand, you know, the cyber side of things, but they do definitely understand the regulatory side of things generally, right?
Yes.
Absolute. And to be honest, I also, when we are talking about security by design and also by the regulation, in the end of the day, you have to know your product, because we are talking about developing a product and selling it into a market. And that means for me, if I'm a product owner or product manager, I have to also see, okay, in which market do I want to sell and what are the requirements from the market? Is it a regulated market like the utilities? And then we have dedicated requirements. For North America, we have the NERC ZIPs. Here in Germany, we have more following the 62443 and the BDEV standards that are in place. And in the end of the day, it comes to, okay, I want to design, I want to enter into a market, and I have to follow those requirements. And we are not talking about consumer products in the end of the day. Who then says, okay, yes, we can build in some security in a surveillance camera or what, or in a Fitbit tracker or whatever. But I think in the end, when we are talking about products in the industrial side, we have to follow the standards, or like in the railway environment, there are dedicated standards, and that are my guidelines. That are my road, where I have to follow, and that is my path, which I have to follow. But we have to take into account that, and that is what we learned also in the past in other areas, in other markets, in other segments. Don't be inspection ready, when you are implementing a standard, or a procedure, how to develop a secure software, how to implement secure software. Be combat ready, be ready for the real fight. So don't follow a standard that says I fulfill for chapter 1, 2, 3, 4, 5, and then I have everything in a check mark. So design a round product, with a proper lifecycle, secure updating process. As Guillaume mentioned, the underlying hardware, it's also a foundation for everything. And that is for me. And looking into what's happened into the standard world, especially in the industrial side, upcoming standards are also covering all of these points. OPC UA is covering the whole security lifecycle. The new draft, it's now a release candidate, the 21, is covering the whole security provisioning lifecycle, from a component to a machinery up to your whole plant environment. And that is for me the next level. We are not talking only on issuing some device identities. Now we are talking combining these devices, these components into a machinery, into a control network, and secure everything. And that's the OPC level. Then we have the Brisky, Anima in the IEEE environment where we see it. The new meta standard for the home, smart home and smart building environment has security requirements built in. And so we are now seeing step by step coming up. And to be honest, I think especially on the OT side, on the industrial side, these guys, they learned from the mistake we made in the IT in the past. And I see it, and I like this direction.
Yeah, I really like that, Andreas. I always consider that, like, use compliance and laws and regulations to help you get your work done, but don't be fooled into thinking just because you're compliant that you're secure, right?
Yeah,
That's a great point.
yeah, absolutely.
I feel like that should be a t-shirt slogan or something. Oh, great. Good thoughts, guys. I really appreciate this. Cool. All right, any other things on standards? I know there's some chats also, so lots of audience interest in that as well. So maybe if we don't get to all that, you can always contact us afterwards, or we can see how to give you some lists of things.
Maybe I can pick up one question. Do we see, do the panel see the benefit from official certification, or would self-declaration be sufficient? I only want to point into the direction. I'm from Germany, and the European Union has launched a first proposal about how to classify in Europe the IoT devices that you want to sell into the market. Classify in 3 categories and 3 security levels, and there are security requirements underneath. And that's the direction now. And there's not longer a question, do you benefit from a certification? You need a certification to sell in Europe. That's it. I think so. I think from my point of view, right direction, that we are steering, especially here in Europe, and it's now up on the ENISA and the European Commission to see how we implementing the auditing and compliance process.
Yeah, great.
I think just quickly on the self-testing or self-attestation part, that's a rarity. I think that's not going to get ratified, at least from what I've seen. There will be certification bodies that do a lot of that work in the regions that we've been working with anyhow. It'd be very rare to be able to self-test or self-validate, let's say.
Makes sense. Okay, all right, let's I want to talk a little bit about manufacturing and supply chain and how those pieces that we all have to deal with when designing, developing, and producing a device or a system. How do we think about components of that might be at risk as we're going through security by design? So maybe Morel, I'll pass it over to you to kind of talk through some components that we need to be aware of there in supply chain.
Yeah, sure. Maybe again, I'll separate it into 2 separate buckets here. One is the vetting of the supplier. I think that's a very, very critical and important step. So this is, by the way, a large topic in and of itself, but so having adequate vendor supplier cybersecurity vetting processes is very important, whether that's getting a hardware component from a certain manufacturer, or whether it's a software component, or whether it's if you're outsourcing certain development into a certain third-party vendor as well. So there's guidance on this as well. NIST have released some guidance on how to establish this questionnaire, because it can be as simple as a questionnaire. You would ask certain questions, you would receive responses, you'd have a checklist criteria that you would follow, and you would deem that vendor suitable for your specific operational need. So that's one bucket in terms of vetting third parties. I think a second one, which is getting a lot of airtime as well, when we are designing software and when we're developing software, we tend to use a lot of open source libraries, right? Or we tend to use a lot of open source code that's available. So something new, not that new, but a term that's getting out there is an SBOM, or a software bill of materials. So making sure that when you are doing some development work, that you do keep that software bill of materials. And this is important, as we saw recently by some incidents that have occurred. So we can know which open source software has a potential vulnerability that is being exploited, and we can go in and fix that so it doesn't impact the operation of our product. So two things: supplier vetting, there's this supply chain vetting process that you can refer to, and then there's an SBOM or software bill of materials that you would keep on the development side as well.
Great, thank you. Makes sense. So that kind of leads me into another term that we often hear, and it's called zero trust. But zero trust for IoT, what does that mean? So what does that mean when we're talking about factories, factory systems, control systems, but then also even production of connected devices, and how to ensure that the devices that are actually made are, these unique identities. So Guillaume, you talked about this, putting a unique credential. How can you trust the origin of that credential when you're, perhaps producing in multiple factories? So can you, maybe Guillaume, if you could start the conversation a little bit here around zero trust for IoT. How do we think about that?
Okay, so zero trust comes from the world of IT, and basically the idea behind zero trust is don't trust any device, anyone, any network, only grant access and talk to devices with granting minimum privileges, and spend your time checking and rechecking and rechecking and monitor. So zero trust is a very different approach to the approach that IT networks used to have, especially in the factory. Well, no later than Monday, I was talking to a customer, a bank, and their factory is office buildings, basically. So they used to operate their building automation and their systems, so elevators and heaters and HVAC and lighting and everything that brings comfort and security into the building. And until now, every building has its own dedicated network for that. So they have Ethernet cables uniquely for that purpose inside the building. And there's an IT room inside the building that takes care of gathering and controlling and monitoring. And there's staff trained in the building that takes care of that system. And what they want to do, they want to centralize, and they want to bring more automation, and they want to do that across more buildings. And all of a sudden, if they have to do that, it means that the data needs to go outside the buildings themselves and maybe to use the internet. So all of a sudden, they cannot trust their perimeter anymore. So whereas a few years back, it was okay maybe to trust the perimeter and to say, okay, I completely control my infrastructure. I know that cable and I know where it's going. I know where it's coming from, and nobody can plug on it. Now, if your data has to leave that perimeter and to go somewhere else, in between, you trust nobody. So that means that you have to change the way you do things. And the way you can do that is by implementing zero trust. So basically, never trust anybody. And how can you never trust anybody? It's by constantly asking the machine or the person you're talking with their identity, their passport, to prove their identity. And then you have cryptographic means to check that identity. And you have ways to know that you're talking to the right machine or the right person, and even machines talking between them, they can do that very often. And for us, it's a burden to constantly show our passport for machine showing certificates all the time is only a small overhead. So on the communication. So basically that's zero trust. And the way you do that again is with strong digital identities based on certificates, because that's the state of the art today. So in the industrial IoT, a factory can be a factory and a closed factory and a facility, but imagine now that you're a utility and you're deploying smart meters. We already touched that. So all of a sudden you're distributing water, for instance, or electricity. And what's your factory? It's probably some facilities that you have where you pump water, but it's also every smart meter in every location that you're distributing water. So your factory, the concept of factory can spread out very, very far from the image that we have. And that zero trust paradigm needs to apply now every time, just because of that, because IoT means that we're spreading out on its side, IoT or industrial IoT, and one I that stands for internet, which is nothing to trust.
Thank you. That's great. Does anyone have anything else to add on to that? Andreas, I'm kind of looking over to you now. Any thoughts around how to actually imprint these kind of strong digital identities, you know, when you might be in environments that you don't trust? Anything from your perspective that you've seen as well?
Yeah, I think from my experience, so I think 2 years ago, I had a project together with Siemens. I can name it because you can also find these guys some videos from our tech days that we had in Sweden, where they were talking about this, and there was a challenge for us that we said, okay, how to secure the imprinting of device ID inside a manufacturing site here in Germany or in Austria or in Switzerland. It wasn't a big deal. So yes, we have to follow all the requirements. There was network segmentation. That is very often a burden when you are integrating some security mechanisms. But then the huge question comes up: what about China? We have location in China where we are producing. Okay, you say, oh, no problem, we can ship it. Yeah, but you have a security chip on your board. You cannot import security technology into China. How you are handling this? So how do you? And you can. It is possible to chip security into China, but you have to open up all the algorithms and all the mechanisms, all the implementation. So you have to switch into a software version, and then how to control this. How to control the imprinting technology and imprinting mechanisms in an uncontrolled environment. And that was a huge challenge. That is something you have to take into account when you're designing a product and you're in the design phase and you think about the life cycle and imprinting the birth certificate, imprinting the initial device. And that's a foundation. As Guillaume mentioned, that's a foundation where you're building trust. That the underlying trust. But I don't want to stress this point. Also, the life cycle itself on a product side also means when you are updating and, for example, you are adding patches, adding a new software version. That's on the same level of security and on the same trust level that has to be established, the update process as the imprinting process. Because this is the next point of vulnerability where you can enter into the device. But I think in the end of the day, zero trust, it's not only the network concept itself, also the behavior of the device must be appropriate to a zero trust strategy. Think about yourself. You have public spaces like an airport or a train station where you're entering in and where we have an open network where you're connecting with your environment. But you as a person with your equipment, you have to activate, or you have to act in a secure manner, and you act in a secure manner. You don't open up your age if somebody comes to you and says, hey, how old are you? You don't do this. And that is how your device should also behave in a networker. Are you trusting a self-signed certificate from an OPC server that you don't know? It's common today. It's common today. Yeah. So looking into manuals of manufacturers, named manufacturers in the world here, and they says, oh, you need a TLS certificate. Here is the guideline how to generate a self-signed certificate. That's a ticking time bomb. And that is, from my point of view, that is the lack that we have today in the field. Everybody's talking about strategies, zero trust concepts, but the implementation and also the devices are behind this, definitely.
Yeah, great points. Thank you, Andreas. We're getting better, I think. I feel like that these conversations and best practices and the whole everything we talked about, from guidelines and recommendations, it's all moving in the right direction, but it takes a while. Okay, so just looking at the clock, we are sort of wrapping or getting close to the end of the time, and I do want to leave a few minutes for each of our panelists to just have some closing thoughts. But before that, there was some additional questions in here I want to make sure that we can answer. So Maura, actually, I see that you've raised your hand here. We have a question called, as a percentage, how much of the product cost would need to be allocated for making sure that secure design is happening properly? Do you have thoughts on that? And actually, it looks like maybe we are starting to wrap up. So with that, sorry if we didn't get a chance to answer final questions, but I really appreciate you all having us for today. Thanks to all the panelists for preparation and for your expertise. It's been a really great discussion. Thanks again to our sponsors, as I mentioned earlier, Building Cybersecurity Organization, Fortinet, Eurotech, Keyfactor, Verve, and Zona. The support of them really enables us to be able to have great conversations like this. So with that, I'm going to wrap it up, and we're going to move on to the next session, which is called Leveraging Attack Surface Management. So hopefully you can stay on for that. And please, as you see on the screen, rate this session. We really want your feedback so that we can then target these future discussions and future sessions. So thank you very much.